Good morning, students. Today we shall discuss on Hermite polynomials. So this is your Hermite differential equations, and the solutions are nothing but Hermite polynomials. And in the last video lecture we were discussing about differential equations, or the first order and second order differential equations. Wherever we find wave equations, so those wave equations can be represented in terms of differential equations, either first order differential equation or second order differential equations that we know already. The solutions of differential equations which should satisfy the differential equations. Okay, so you have a differential equation, the solutions that we are going to assume are exact solution that should satisfy this differential equation. So only then we can have the solution exact. And one of the differential equations which we use today, we have nothing but Hermite differential equation. So wherever you find this type of equation, immediately you can guess that this is your Hermite differential equation. The solutions are nothing but Hermite polynomials, especially when you are going to have the concept of linear harmonic oscillator in quantum physics. In linear harmonic oscillator, the differential equation is nothing but exactly of this type. The solution is nothing but Hermite polynomials. So we'll be studying in the next semester about linear harmonic oscillator. So we'll discuss now the Hermite polynomials. So this is your Hermite differential equations. Okay. So the Hermite polynomial denoted by h n of x. So this is h n of x, where n goes from 0, 1, 2, 3 goes on, is the solution of the Hermite differential equation, which is given by this. So wherever you find this type of differential equation, and you can say immediately that this is Hermite differential equations. Okay. So d squared y by dx squared minus 2x dy by dx plus 2ny equals 0, where n is a constant. Now we are going to solve this differential equations using a power series method. So we are going to use power series. We are going to assume that y equals sigma r equals 0 to infinity a r x to the power k minus r. So this is the power series method. We are going to solve this differential equation using this power series method. Okay. Now, so this is your power series method. Y equals sigma r equals 0 to infinity a r x to the power k minus r. So look at the differential equation. We have the first order and we have the second order. So accordingly, we can differentiate only once. We can have this. We can differentiate 2 times. We can have this. I repeat. So you have the power series y equals this term. You just differentiate with respect to x here. So you will get a r x to the power k minus r. So k minus r x to the power k minus r minus 1. Is it okay? Now you will have to differentiate again with respect to x. So differentiating again, that will give you same thing, a r k minus r. So you have to differentiate now. So this becomes k minus r minus 1 x to the power k minus r minus 2. So we have now dy by dx and d squared y by dx squared, and also we have y. We can substitute in this equation. See, we have the answer for this. We have the answer for dy by dx. We have already known y. You substitute in this equation. So after substituting, we will get this. So this is d squared y by dx squared. This is 2x dy by dx. This is your 2n y equals 0. Any doubt? This is your differential equation. We have already got the expressions for this term, and this term. We have substituted here. Okay. Now I am going to keep this term as it is. Now here you have x to the power 1, and here x to the power minus 1 is here. So both will get cancelled. I repeat, here you have x to the power 1, correct? And here you have x to the power k minus r minus 1. I can separate into x to the power minus 1. That x to the power minus 1 and this x to the power 1 will get cancelled. You will have no x here, the second term. Okay, simple. And you have 2n as it is. This term is as it is. So now this equation can be simplified as this. I am going to combine these two terms, pulling 2 out. I have pulled 2 out. I am going to combine second term and third term. So you have now, I have pulled 2 out. The common terms ar x to the power minus kr. The remaining term will be your n is here. See, n is here. Your minus k is here, and minus plus, that will be plus r. Is it okay? So I have combined second term and third term and I have written here. Any doubt? Equation 5, which is very important, often will be using this. So here the first term and we have combined second term and third term, we have written in a single term. Okay, taking common terms out. So I have written the same equation 5. Now, very important thing, just listen to me, it's very important one. Now we are going to equate the coefficients of highest powers of x. So now we are going to equate the coefficients. Here we are going to equate first the coefficient x to the power k. But here x to the power k minus r. Here it is x to the power k minus r minus 2. Suppose if I put r equals 0 here. So you will get x to the power k alone. Here it is x to the power k minus 2 will be there if I put r equals 0 here. Okay, so I can go with only one term for the coefficient x to the power k, this term alone. I repeat, when r equals 0, you will get x to the power k alone. This term which will have x to the power k minus 2. So this will become 0. There is no term. There is no coefficient of x to the power k. We are going to equate the x to the power k on both sides. Okay, when r equals 0, you will have only this term alone. So this term will become, when r equal to 0, this term becomes 2a naught, correct, n minus k plus 0, which is equal to 0. There is no term here x to the power k. So that's why I have written as 0 here. Now 2a naught n minus k equals 0. Okay, now possibility is there. One possibility 2a naught equals 0 or n minus k equals 0. There are two possibilities. Now when you are going to go with 2a naught equals 0, 2 cannot be equal to 0, the possibility is a naught equals 0. The first term a naught cannot be equal to 0. You just imagine the first term, a naught is the first term. Look over here, this is your series. Okay, when r equal to 0, it will become a naught, x to the power k. When r equals 1, a1 x to the power k minus 1. So something goes on. So now the first term, look over here, when the first term a naught cannot be equal to 0. We can't fix up the first term will be equal to 0. We can't fix it up. So here a naught will not be equal to 0. So possibility is n minus k equals 0. When n minus k equals 0, n equals k. We will be using this often. N equals k. So you remember this one. Okay, equation 6. Now we will go with x to the power k minus 1. Now we are going to equate the coefficients having x to the power k minus 1. So x to the power k minus 1, that will give you r equals 1. Okay, r equals 1. So this becomes x to the power k minus 1. What of this term? X to the power k minus 1 minus 2. So this will not have k to the power x to the power k minus 1 will not have. So this will become 0. Again this term alone will exist. Is it okay? So you will get only 2a naught, 2a1, r equals 1. So 2a1 n minus k plus 1 equals 0. I repeat. See here, this becomes a1 n minus k plus 1 multiplied by x to the power k minus 1. So we will get this expression. So this says clearly that a1 equals 0. Second term, a1 equals 0. Okay, so a naught is not equal to 0, the first term. The second term, a1 equals 0 now. Now we will go for equating the coefficients of x to the power minus k, x to the power k minus r. Okay, we are going to equate now. X to the power k minus r already exists, so no need to simplify. But here there is a tricky. Here what you are going to do is x to the power k minus r minus 2 is here. I am going to write r as r plus 2. Okay, I am going to write r as r plus 2. Suppose if r plus 2 is there, then that 2 or minus 2 will get cancelled. You will have k minus r. Is it okay? I am going to write this term r as r plus 2. So you have x to the power k minus r alone. That minus 2 and plus 2 will get cancelled. So we can equate these two. Now r becomes r plus 2. R becomes r plus 2. Already one minus 1 is there. So you will have plus 1. R plus 1. Is it okay? Now what of this term? Summation goes from r equal to 0. We have written r equals r plus 2. We have added two terms. R equals r plus 2. But summation should start from earlier two terms. Is it okay? See, we have added two terms and we have written x to the power k minus r. The summation will go behind, okay, behind r equals minus 2. Is it okay? So we have added two terms. Already summation starts from 0. We have added two terms. So it has to start from minus 1 and minus 2. So this equation becomes r minus 2, k minus r plus 2, as I said, k minus r plus 1. This is the first term. And second one as it is, 2ar n minus k plus r equals 0. Is it okay? Now you keep this term here. You bring this term to that side with a minus sign. Is it okay? You just keep this term here and this term to that side, right hand side, with a minus sign. So AR becomes, I can write as AR becomes this term divided by 2AR n minus k plus r. 2n minus k plus r. This term I have written minus AR minus 2 as it is. AR minus 2. Any doubt? Very, very important. Now, as I said earlier, that you have to remember k equals 1. You substitute for k equals n, you will get AR as this equation, equation 8. So, AR becomes minus n minus r plus 2, n minus r plus 1 divided by 2r, AR minus 2. So, equation 8. Any doubt? AR? Now, you substitute r equals 2 in this equation. R equals 2 here. So this becomes A2, this becomes 2 minus 2, A0, R equals 2 means you will get minus N, R equals 2 means you will get N minus 1. Already we have found out A0, then A1, this is A2. A2 in terms of A0. Then suppose we are going to find out A4, that will be in terms of A0 again. A2, it will be in terms of A2, A2 is in terms of A0. So all even numbers will be in terms of A0. Simple idea. What are the odd numbers? Odd numbers, A1 equals 0. So A3 must be equal to 0. So A3 will be in terms of A1. A5 will be in terms of A3. A3 is in terms of A1. So all odd numbers will become 0. All even numbers will exist. So this is it. Is it okay? So now A2 becomes minus n minus 1 divided by 2r. So we can write this as 2 square A0. So what if r equals 3? Substitute the same equation. We will have A3 equals minus n minus 1, n minus 2 divided by 2r. 2r it will be. So 2 multiplied by 3, A1. But A1 equals 0 already. So A3 must be equal to 0. So we can conclude that A1, A3, A5, A7, A9 all will become 0. All odd numbers will become 0. Is it okay? Now we will go for r equals 4 here. The same equation 8. So you will get exactly like this. Here this will become, this will have 2 multiplied by r. R equals 4 here. So you will get 2 multiplied by 4. You will get the same equation in terms of now A2. A2 exists. Correct? A2 exists. Here A2 term is there. It is not 0. So A4 is in terms of A2 now. Of course A2 is in terms of A0. So A2 is here. Correct? So A4 equals this one. You substitute for A2. A2 is given. You substitute for A2. You will get n minus 1. See here, you have minus sign. This minus sign and this minus will get cancelled. You have n minus 1, n minus 1, n minus 2, n minus 3, divided by 1, 2 squared is there already. We have 1, 2 multiplied by 4. Okay, so this will be 2 squared. Already 2 squares are there. See, 2 squares are there. So you will have 2 to the power 5. So 1, 2, 3, 4, 5. Correct? See here 2 squared. You have 2 squared multiplied by 2 to the power 3. Here it is 2 squared. So totally you will have 2 to the power 5. Is it okay? So this can be written as simplified as 2 to the power 4 multiplied by 2 factorial. We will see later. Okay, 2 to the power 4 multiplied by 2 factorial. Now we know that the power series starts from y equals sigma over r equals 0 to infinity ar x to the power k minus r. You substitute now r equals 0 here. You will get the first term. Correct? K equals n. Of course, k equals n. So you will have first term a naught x to the power n. What is the second term? R equals 1, a1 x to the power n minus 2. So a1, but a1 equal to 0. So you have to go with the next term. R equals 2 here. So a2 x to the power n minus 2. What about a5? a3 0. What about a4? You substitute a4, you substitute for r equals 4. So a4 x to the power n minus 4. So these are all your expansion, power series method. You have expanded in terms of x. Is it okay? Now, so now we have found out the value for a naught, we have found out the value for a2, a4, you substitute. Okay, not a naught, we have found out the value expression for a2, a4, everything in terms of a naught. So you can pull a naught out, everything in terms of a naught. So you have a naught x to the power n, this is your a2 and this is your a4. All a1s, a3s are 0. So a naught we can write exactly as this expression exactly like this. Now I am going to multiply and divide by n minus 2 factorial here in this expression. You have this expression, I am going to multiply and divide by n minus 2 factorial here. Okay. Now I am going to multiply and divide by this term as n minus 4 factorial. Here n minus 4. Remaining terms let it be like this. Going to multiply this term with n minus 2 factorial by n minus 2 factorial, multiply and divide by n minus 4 factorial divided by n minus 4 factorial. See now the first term let it be like this. Okay, n into n minus 1, n minus 2 is nothing but n factorial, which you have studied already. N factorial is n into n minus 1, n minus 2. Okay, then 2 squared x to the power n minus 2. Okay, 2 squared I can bring it to the numerator. So that will be 2 to the power minus 2. Let it be x to the power n minus 2, let it be. Now the remaining term will be n minus 2 factorial. Now plus. As usual, n into n minus 1, n minus 2, n minus 3, n minus 4 factorial is nothing but n factorial divided by, you just bring this term 2 to the power 4 to the numerator, we got 2 to the power minus 4, 2 factorial n minus 4, the last term let it be like this. So we have simplified the expression for y. So now accordingly we just put a naught equals 2 to the power n, you will have the total Hermite polynomials. So which is y equals hn of x. This is the solution. The differential equation, the Hermite differential equation, the solution is nothing but your y. Y is nothing but a Hermite polynomial. So y is nothing but your hn of x. Hn of x equals, for a naught you substitute 2 to the power n, remaining term let it be like this, the remaining terms. Now which is equal to, you multiply this inside. So you will have 2x to the power n minus n factorial, 2 multiplied by n, that will give you 2x here, 2n, one mistake is there. So this is your x to the power n minus 2, correct? 2n multiplied by x to the power n minus 2. So that will give you 2x n minus 2, correct? Is it okay? So you have 2x n minus 2. Is it okay? 2 to the power n, I repeat, see here 2 to the power n, you have 2n, 2 to the power minus 2. You combine all those things, that will give you 2x to the power n minus 2. See here, I repeat again. 2x to the power n minus 2 can be written as 2 to the power n minus 2, x to the power n minus 2, correct? 2 to the power n minus 2, x to the power n minus 2. So it's correct. Simple one. So we have now plus the term, let it be like this. We have now n factorial, the same idea, 2 to the power n, that can be written as 2x to the power n minus 4 divided by 2 factorial n minus 4 factorial. Is it okay? Is it okay? Multiply and we have simplified. Now this series can be written as exactly like this. This series can be written as. So we have simplified in terms of summation. We have simplified all those terms in terms of summation here. See, as it is left hand side as it is. Here I have written as, 1 minute, just we have changed the limits now. N minus r is greater than or equal to 0. You have n minus r here. This is your n minus r. N minus r, 2r is greater than or equal to 0. which implies that 2r is less than or equal to n. So r equals n by 2. So r goes from 0 to n by 2. This term I have simplified exactly like this. This term, total this term. Okay, how it is possible? We'll see. Now when r equal to 0 here, you substitute r equals 0 here. When r equals 0, this becomes plus 1. When r equal to 0, this becomes 2x to the power n. See, first term, 2x to the power n. Denominator, r equals 0, this becomes 0 factorial. 0 factorial. And this becomes n factorial. So this is n factorial, this n factorial will cancel, you will have first term. Is it okay? What is second term? We will try for the second term. r equals 2 here. When r equals 2, this becomes 2 factorial. Okay, let it be 2 factorial. Now this becomes minus sign. Minus sign or plus sign? Plus sign. So minus r to the power minus 1 to the power r 2x n minus 2r divided by n minus 2r factorial. Okay, you substitute here n equals 2, you will get this. When n equals 4, you will get this one. Okay, we have done n minus r greater than or equal to 0, and you can simplify this as 2r less than or equal to n, r equals n by 2. So we have done r equals 0 to n by 2. N by 2. Is it okay? You just substitute now r equals next term, r equals 1 here. When r equals 1 here, you substitute here, r equals 1. R equals 0, next term will be r equals 1. You substitute r equals 1, this becomes minus sign, so minus sign. When r equals 1, this becomes n minus 2, correct? n factorial 2x to the power n minus 2. What is the denominator? R equals 1 factorial, n minus 2. So this is n minus 2 factorial. Is it okay? R equals 3. You substitute r equals 3. You will get the next term. R equal to 4, you will get the next term. Okay? R equals 4, you will have to go with the next term.